Hello everyone and welcome back to this next lecture. So in the previous lecture we had compiled this deadband example where we had implemented a rising edge and a falling edge deadband on both EPWM1 and EPWM2 and in such a manner that we eventually produced two rising edge delays on both our waveforms at the final pin outputs. So in this lecture we are going to verify that for ourselves. So again, I'm going to bring the microcontroller. This time we're going to verify it with the TMDSDOCK28069 kit. Right? So I will bring the microcontroller into the video. So as you can see, the connections in the microcontroller are exactly the same as in the previous example. So for example, I have connected the 4 pins of the GPIO module, that is GPIO 0, GPIO 1, GPIO 2 and GPIO 3. These 4 pins are serving as EPWM pins, that is EPWM 1A, 1B, 2A and 2B. Alright, so these 4 are connected by jumper cables to the solderless breadboard, and here we are connecting our oscilloscope probes. Right, so with this I'm going to zoom into the oscilloscope because that's all there is to see, and I'm going to start by downloading the code onto the microcontroller. So the code has been downloaded. I'm going to run the code. And now you will see a waveform. So this is the waveform on pins A and B. So pin A is connected to channel 1 and pin B is connected to channel 2. And if you look now, let me go and zoom in a little. You will see that now there is a rising edge delay. And this rising edge delay can be found on both of them. So for example, you will see that it is not just in channel 1, it's also in channel 2. So for example, what this implies is when the gating signal for pin A goes low, then the gating signal for pin B is delayed by the rising edge delay. And in the case of pin B going low, the gating signal for pin A is delayed by a certain rising edge. So this way we see that these rising edges have been implemented, and now there is a dead band and not just the gating signals being complementary. So with this, I'm going to end the microcontroller video. I would recommend that you can go around and try to play around with this particular example. Like for example, you can increase the rising edge delay, you can decrease the rising edge delay, see what you can achieve. And also if you have any data sheets corresponding to any power devices that you may be using, try to implement delays corresponding to those data sheets. So give that a try. So with this, I'm going to end the microcontroller video. And I can also terminate this particular project. So with this we are done, and the good news is that with this implementation of the deadband, we have now achieved our first practical PWM example. That is, we have now generated gating signals of a particular frequency according to any particular logic. That is, we have used sine triangle modulation in this case, and finally, most importantly, we have generated gating signals which implement a dead band, and so they can actually be fed to a power converter. Right? So this is now a working practical example. If any of this did not work, or if you were trying something else, such as the other option which I said is that you can use, instead of the in mode 1, you can also use in mode 2. So if any of this did not work, post in the Q&A forum and I'll be happy to help you out. Otherwise, in the next lecture, I will get started with synchronization. Thank you so much for listening and see you soon. Goodbye for now.